Hello, mathematicians. This chapter we are going to talk about systems of equations. Systems of equations are two or more equations two or more equations with the same variables. Two or more equations with the same variables. For instance, x plus y equals 6, and then if I have another equation with x and y, they both have x and y. So two or more equations with the same variables. One method that we're going to use is graphing. Okay? So today we're going to be graphing our equations, and we're going to make lines. And the point xy, where the two lines intersect, is your solution. So the solution to a graph is where the two lines intersect or cross. Later in the chapter we'll be algebraically solving them, and that's where the point xy makes both equations true. So what we're looking for is we're looking for the values that fit here to make both equations or all the equations in our system true. There are three types of solutions that we're going to have today. We could have intersecting lines. So when we graph those, we could have intersecting lines. The solution is where they cross. So it'll be a point. Coordinates. So your solution for x is your x value, and your answer for y is your y value. What do you know about parallel lines? They never cross, so there is no solution. And that is the symbol for no solution. No solution because they never cross. So for those equations, there is no value for x and y that make both true. And then we can graph and have the same line. So if I graph the first one and then I graph the second one, they're exactly the same. Infinite solutions. Okay? That means every point on the line is a solution. All of those values work. So this would have infinite solutions because they overlap. So anywhere on the line would be a match. So based off of a graph, we are going to determine the number of solutions. So I'm looking for where they cross or intersect. So for number one, let's find these equations. Y equals x plus 1, negative x plus 1. That is right here, so this equation is on here. And our next one, negative x plus 4. So I have this line, and I have this line. I'm looking for where they cross. How many times do these two cross? None. Will they ever cross? No, because they are parallel. So this answer would be no solution. They are parallel, so they never crossed. Try the next one on your own. Let's see how you did. X minus y equals 3. It's right here. And y equals negative x plus 1. Do these two lines cross? Yes, they cross right here. So there is one solution. And what is the point there? 2, negative 1. So x is 2, y is negative 1. So if you were to plug in 2 for x and negative 1 for y into both of these, it would work. Nice job. Now we're going to graph and find the solutions on our own. Okay? So When we graph, we need to decide if we're going to use slope-intercept form. All right. So if the y and x are on other sides, or y equals mx plus b, we can graph in slope-intercept form. And then here, since x and y are on the same side, we could rewrite it in slope-intercept form, or we could use x and y intercepts. So for the first one, I'm going to use slope-intercept form, y equals mx plus b. So just like last chapter, our intercept is 5. And what is our slope? -1. How do you move a -1 slope? Down 1, over 1. Down 1, over 1. And that pattern continues. Use a ruler or a straight edge and connect those. There is our first graph. Now we need to do the next one. And I said since x and y were on the same side, we should use probably x-intercept, y-intercept. What do you know about the x-intercept? Y is 0. So 2x plus 0 equals -8. X equals -4. 1, 2, 3, 4. And now how do I find the y-intercept? Plug 0 in for x. So 0 plus 2y equals -8. Divide by 2, y equals -4. So 1, 2, 3, 4. If I connect those, use a ruler or a straight edge. What do you know about these lines? They are parallel, so there is no solution. Parallel lines have no solution. Let's take a look at number 2. Our first equation, how do you want to graph this? Slope-intercept or intercepts? Let's do intercepts because x and y are on the same side. So x-intercept, which one is 0? The y, so x minus 0 equals 2, which means x equals 2. What about the y-intercept? Plug in 0 for x, which is just -y equals 2. There's a -1 out front, so what must we do? Divide by -1. Y equals -2. Okay. So plot both of those intercepts. Connect them using a straight edge or a ruler. That is one of our graphs. Next, what would you use to graph this equation? Slope-intercept or intercepts? Intercepts again. Go ahead and find the x and y intercept and graph that line. Let's see how you did. X-intercept. Plug in 0 for y and you get 2x equals 9. Divide by 2, and what'd you get for your intercept? 4.5. And lastly, you found your y-intercept, and how do you find your y-intercept? Plug 0 in for x, so 3y equals 9. What'd you get for your y-intercept? 3. So when you graph these, use a straight edge or a ruler. How many times do these lines cross? Once. One solution, and what is that solution? 3, 1. So if x is 3 and y is 1, both of these equations would be true. So your solution is x is 3, y is 1. Go ahead and try number 3 on your own.